right, guys, we're back. Had some video technical difficulties, but we're back. If you didn't watch the stream about a couple minutes ago, we are working on a Ford Econoline van. This is just a custom van conversion that a customer picked up. I did not do this van conversion on the inside, so the previous owner did this. Simple bed, wood construction, there's a fridge, a little kitchen galley, all that good stuff. So fast forward, we are putting in a new battery system, a new DC to DC charger, and a new inverter charger. So what we're doing, we've got let's head on over to the other camera. So this camera is what we had some issues with earlier. Hopefully it is all fixed. Okay. This is the nice new camera. So I think the issue was the computer. It didn't, actually the HDMI cable. It was too long. So we're losing some signal. Anyway, enough nerding out on that. So what we have is the Renogy 2,000 watt pure sine wave inverter charger. And we're going to be using that with a 30 amp DC to DC MPPT charger combo. So this is the one that I have in my personal van. I've also put this in the Glacier build. The Glacier actually had 2 of these, and they were rated at 50 amps. But on older vans and just older vehicles in general, I recommend not going over 30 amps because depending on the life of the alternator, you don't want to wear it out even more because the less you can tax it, the better. So this is an older van. This is about a 25-year-old van. So we're just going to cap it at 30 amps. The nice thing about this unit right here, we'll open it up in a second, but this DC to DC MPPT combo charger, as it states, we're getting 30 amps coming from the engine, from the alternator, but then we also have a solar charge controller built in, hence the MPPT. So it's convenient for her in the future if she wants to expand, put a solar panel on the roof. There's actually no room to do that because she has a massive AC unit up there, and it's a fiberglass roof. I don't really want to drill into it or anything like that. Long story short, there's future upgrade opportunity. And this one's really nice to set for your lithium charge profile. Easy to do. And then down here, so we got engine charging here. Down here, this is the main thing we want to fix. So in this van, the previous owner installed this lead acid battery. It's not AGM, it's not sealed. In this box to enclose it, and then there's some plumbing parts to vent out the gases that come out of the battery. So not the safest option. I did mention that, and that's kind of how we went down this rabbit hole. Because I'd actually previously done some just repair work. This bed is on some shocks, and those gas shocks had failed, so I replaced them so she could lift the bed up and down. Her passenger door latch was broken, so I fixed that so she could enter the vehicle from the passenger door. She was having to go inside and unlock it, then get in. Not convenient. I fixed that, and then we got to talking about this, and she wanted to know if I could upgrade this, and I said absolutely. And this is done on a budget, so if you want to know my opinion on, this is the lowest I would go product-wise. So I have a lot of experience with these Renogy inverter chargers. Never had an issue with them. I really like these right here. They're just simple. So some people have a bad rap on Renogy. I haven't had any issues. And even if you do have an issue, just understand the price point that you're purchasing things at, it comes with the territory. So if you buy a lower cost product, just don't set your expectations as high as you're buying a high-end product. So that's just kind of my advice on that. But yeah, should have no issues with this for a long time. Now, what are we doing? We're replacing this battery with a Li-Time battery. Again, this is for cost. But Will Prowse's DIY solar channel, he cuts into batteries. He does a lot of battery testing. And so this Li-Time is what we're going to be going with. So let's move the camera over here real quick. All right. So let's get it right. That looks pretty good right there. Hey, by the way, if you guys have any questions, feel free to ask during the live stream. But we'll open up this battery so you guys can get a feel for what it looks like. And then we'll show you what we're going to do. So we're replacing the lead acid battery because we want a sealed battery. We don't want a battery that is venting gases back into the van. Looks like we got some paperwork for the battery. It's kind of nice. Post bolts are here, so these are the 2 bolts that we'll connect the wires to. And this video today is pretty much just going to be showing you what I ordered for the van. Off camera, I'm going to do a bunch of the install because this would just be too long to live stream. But yeah, here we go. We've got the 230 amp hour plus battery. That's what we purchased for this project. And it just happens to be the exact form factor that I needed. As you can see here, it looks pretty wide, but then look how slim it is. It's very slim, width wide or thickness. So it should do pretty well in here. Now, I ordered this after I did a bunch of measurements. It's been about 2 months since the van has been back in the shop, so if the internet is right, we should be fine. So we got 18, 7.5. Then over here we've got, how much room do we have in here? 24 and 10, so perfect. So we're going to take out that plastic box, and then, hey Rod, welcome back. My HDMI cable that I was using was too long. I was losing signal, so the technical difficulties of live streaming. So as I was looking at this morning, over here I noticed I was getting ready to start disconnecting the shore power. There's a shore power plug on here on the outside of the van. And now I don't have enough length to move it, but that shore power on the outside of the van, it is, they cut off the plastic or the rubber sheathing, and it's now cutting into the plug. So probably in a couple months, she probably would have had a short, which is not safe in the van. So I'm going to call her up, and we're going to replace that with a new Furrion shore power plug. And it's the same one that she has. So this is her cable. So this is a 30 amp plug, and see if it's just fine. So we're going to do that for her. And then we'll have a safe place to start from. We'll hook this up. We'll put the inverter is going to have to go back there in the back because we just don't have enough room, as you can see. The DC to DC charger is going to go here. We'll make a little nice face plate because we're going to put a battery disconnect. And then down here, we'll make sure that we rewire everything the way it's supposed to be. This box going into the van, it's fine. There's nothing wrong with that. So all we'll be doing is taking this thing, which is I think this plug is the refrigerator. So we'll be redoing that. She has a 120 volt high-sense fridge, and the goal of this whole project here is to, there is a, can you see it? Let's see if you can see it. There's a roofed, you can't see it there. There's an air conditioner unit. It's a 110 volt AC unit, and it is powered by shore power only. So she has to be plugged in for it to work, because the inverter cannot provide enough juice. And the other problem was she wanted to run the fridge, but she could only run the fridge when she's plugged into shore power to get enough power to run it, because this lead acid battery would only run it for, I don't know, maybe an hour or something like that. So that's what we're solving. We're having it to where things can work normally, so that she can be off grid, run the fridge, and then actually run maybe the AC for an hour or two, which is not a lot, but if you just want to cut the heat off, you can crank it on for about an hour or two. If you're like at a rest stop, having some lunch or something like that. And then you can get to your campground, recharge it, and when you drive, you'll be recharging it as well. So let's get to, let's look at some more products that we are putting into the van. Okay, got the battery. We've got our shore power plug. And this is a 230 amp hour. It's the most amp hours that I could get to fit that battery in that spot, because she did really want to keep as much storage as possible. She has some chairs. She's also a musician. She plays the banjo, travels around to festivals, so pretty cool. So there's not a lot of storage in the van, and we want to just maintain as much as we can. Also, guys, if you're watching live, feel free to ask questions. This is a really good project. This is just a 2-day project for me, so today is just knocking out unboxing, planning, and gutting everything. And then, depending on how late I'm going to go tonight, I might get into some wiring, but you probably won't have an update until tomorrow. All right, next. Renogy. This is a 2,000 watt pure sine wave inverter charger. So it takes power from shore power, like a campground, converts it to a charger to charge the battery. And then the inverter is obvious. That is taking shore power and just doing almost like a 1-to-1 into household power in the van. So this right here, there's a switch inside here. Turn it off and on. We'll install that. This is a battery temperature sensor, so we don't need to install that on the lithium. It has a BMS, battery management system, inside with low temperature protection as well, so it will cut itself off if it's too cold to safely charge, which you always want to look for that. So shout out to Will Prouse, DIY Solar YouTube channel. He takes these batteries, he cuts them open, he tests them, makes sure that the low temperature disconnect works, which is one of the most important things of a, or one of the most important features of a lithium battery. If you charge a lithium battery, around freezing temperatures, it's going to, it's not going to like that. Okay, this inverter charger is very heavy. And for all transparency purposes, this inverter charger, and it's just my combing the internet, this is like a white label product. I think like there's a couple of companies that white labeled this inverter. So if you've seen this inverter in different colors like orange and white, this Renogy blue, it's not a bad thing. The fact that multiple companies are using the same inverter, hopefully, increases the quality. But we're not working with any Victron or anything like that type of equipment, or Battleborn. It's just not necessary when everyone has a budget that they're working with. And so my job is to find the things that I'm most comfortable putting in your van and standing behind that is tailored to your budget. Because if it doesn't meet your budget, you're not going to do any of this. So I need to comb the internet. I need to find stuff that I know is going to work together, but also is realistic to what you can afford. So I've installed Victron components. I've installed Red Arc electronic components. So everything to me, it just depends on what is the best fit. For this application, this is the best fit. So parts and labor for this install, you're looking around the like 3,000-ish price point, like 3,000, maybe 3,500 for these components and the install. So you can look everything up and you can kind of deduct what my rate is for that type of an install, just to give you guys a good ballpark on what to do. Now, if you're doing this DIY, these are great DIY components. They're not scary. It's very simple, straightforward. What we're going to be doing is, now, this inverter over here is very top heavy over here. So you can saw how I almost like dropped it on the table. This side is extremely heavy. From here over is like just almost nothing. So we're going to get everything unpacked, and I'll just quickly, if you don't know what any of this stuff is, I'll just go through this like if you've never seen these components in your life, which hopefully this channel will help you understand what this is. Okay, here's another Renogy component. This is the DC to DC MPPT combo charger. I've installed 4 of these, one in my personal van, and I like them. I like it because it's nice, simple, and straightforward. So here we go. Inside, where's my screwdriver? All right, so I'm going to be opening this up. So this is going to allow us to take our engine alternator that's connected to the engine battery, and in this van, which is connected to a solenoid, so basically what happens is the solenoid is actually we'll be removing this solenoid because that's what this is. There was a lead acid battery in there, and there's a very basic charger you can do, which is like a solenoid charger, and that's going to take when the rear it's going to combine the engine battery with the rear lead acid battery and charge it. Now, we're taking it out because we need more power, but we're also taking it out because of a safety factor. So the lead acid in an engine bay compartment is safe because it's separated by the firewall, and any type of gases that are coming off of that battery when it's charging or getting hot or whatever are vented out. But inside the van, you don't want this inside your van. This is somebody's tried to seal this up to make it safe with some plumbing parts. It's just not a good idea. So the best way to do it is to fix it how I'm fixing it. Okay, DC to DC charger. Got these two caps you remove. So Rod, she does not have solar panels. So we are doing engine charging, and we are doing shore power charging. So that's the plan. And then beefing up the battery that'll fit in there. So this is going to take the ignition alternator, I'm sorry, not ignition. The alternator positive is going to go here. If you did have solar panels, you connect the positive solar power panel here. And then inside here, we've got a bunch of different connectors. So these green connectors right here. We've got, let's see if that will focus. Oop. There we go. I had this thing on manual focus. So right here, we've got this first green spot is for your ignition positive. So when the ignition turns on, this turns the box on and charges your battery. Now, I have installed these and used them. If you can't run this, this has been able to sense the voltage difference and turn itself on, like self-sensing. I'm not promising this is going to happen in every situation, but we're going to install this without plugging in this ignition sense wire. If it doesn't work, I'll go ahead and run one to the back. This second one is your battery voltage monitoring, and this third one here is your battery temperature sensor. This RS485 port right here looks like a network cable. It is pretty much a network cable. That cable can plug into like the Renogy One system, so you can monitor this like on its network. It's like Victron-esque communication, so you can get that experience. I did that in the Glacier build. So the M1 Renogy controller, I plugged it into here and all the smart lithium batteries, and it was able to communicate, displaying a nice LCD screen, and it's pretty cool. So if you want that type of visual control, you can do that with this. Now here, what you're going to see is there's a button you're going to press, and it's right here. You can see that button. You're going to click that button, and you're going to cycle through until you have your battery type. So we want to cycle through this later until the light turns blue, and that gives us 14.4 volts for the charging, the voltage. All right, and then when we're done with that, this light right here will show up blue. And so a blue light here means we are charging with the correct lithium profile. This is going to tell us the status of our battery. It goes, it's like green, yellow, red, almost like a stoplight. Solar, which we won't have connected, and then the alternator that it's charging or not. And then over here, we've got, this is actually what the output is. So negative and positive, this will be going to the to this battery right here. So that's going to go out to this battery. Okay, that's how we get it from the engine to the battery. Next, we have this. So this is our inverter charger. I should have my electric screwdriver, but I don't. So we're going to take this cover off. Just go easy with this stuff because this metal, sometimes it does strip. So okay, this cover comes off, so just put that aside. And then the next thing we want to do is, we've just got 2 more. No, we just got 2 more. Okay, so be careful with this. There's a little plug here. So we're going to unplug this. This is the on and off. Now what we're going to do is, there is a, where did it go? Where's the box at? There is an on and off switch here. Okay, we're going to wire this in. And then that way you're not having to go underneath the bed and turn this on and off. Okay, so down here you have your outputs. So this is your, you got outputs up here. This is the input from the battery. So we'll connect our battery here, and then when we move up here, now this is a battery temperature sensor. Again, we won't need to install this because we have a lithium battery. But if you have a lead acid battery, this is that temperature sensor that came with the kit right here. You just want to kind of glue it to the battery somewhere on the side. So up here, this is the cool part. So up here is where we're going to have our 3 wires. So line, neutral, and ground. And these are the wires that will be coming in through our shore power plug. So our shore power plug, we got 3 terminals, correspond to these 3 terminals. When we open this up, So to open this, if you guys are wanting to install one of these, you're just going to turn it. It's going to unlock. And then what you're going to have is you're going to have your black, white, and green wire. And that will correspond to your line, neutral, and ground. And then our output down here will be, and you guys will, I'll show you how to hook all this up. And then over here, this is going to be the output. So imagine this is like power coming into your house. These three wires will go and connect into the breaker panel. So this breaker panel right here. And then our breakers, we have the red one right here. This is the main power. So I didn't install this. We're not going to mess with this. We're going to keep it exactly how it was wired. We're just going to be supplying it power through the inverter instead of this little baby inverter here. So we'll have that 2,000 watt inverter powering this. The green, this is the for the air conditioner. So this is the air conditioner off and on. The red main is a 30 amp circuit. The green AC is 20 amps. I will verify that this is enough. I don't know if the person that did this knew what the requirements were for the AC unit. I questioned the 20 amps. It's possible that the unit is 20 amps is fine, but my gut tells me 30, so I need to verify that. And then the blue left bank plugs, so the left plugs in the van, and the blue right is the inverter. So this is what's powering this little baby inverter. So the way that they have this connected is shore power comes in direct to this box. When they flip on this right one, it powers this, and then this powers the refrigerator. So we're going to fix all that. We don't want to do that. We are going to have the refrigerator directly connected to this box via this 15 amp circuit. And then that way, actually, see, this is why you really got to pay attention. This label right here is not accurate. So it says green AC 20 amps, but the AC actually has a 30 amp breaker, which that was my gut instinct is it's usually 30. So this is good. That's good. However, the main is 20, which that's good that it's under. So if this is why you got to do all the math on this. So we'll talk about this as I wire it, and we'll make sure that this is all rated correctly. We want to know the AC manufacturer, what is the recommended current to be supplied to it. We're going to check with the Renogy setup to make sure that the power coming up, is 20 enough, or do we need to upgrade this? So we'll go through that. The 15 amp outlets, these are fine. And then over here we have, these are 12 volt circuits. So yeah, a little bit of figuring out to do, but nothing that has not been done before. Actually, can we take this off? Okay, so these are Westinghouse breakers. What's nice is usually you can find these at Lowe's or Home Depot. So if they don't meet my specifications, we'll go find some and upgrade them. And then over here, has there's not really any 12-volt accessories back here that we need to power. However, I do want to make sure this works in the future in case she does want to use this. And then we'll be doing away with this. The DC to DC charger will go here. Yeah, looking pretty good. Let's go through the rest of the stuff I got, and then we'll get into taking some stuff apart and answering your questions. So Rod, I agree with you. 20 amps does seem low for an AC unit, but this is a, let's see here. Let's figure out what the name of this AC unit is. I think it's a Coleman Mach series. This is a Coleman Mach, just a Coleman Mach. It's not like a 2 or 3 or whatever. Yeah, just a Coleman Mach. So. Let's see here. If we do a internet search. And it's an old one, so I don't know. Coleman RV. Let's see. I mean, it doesn't look that old. This is what it looks like. It looks like this one right here. So this is Mach 8 Plus. 18 amps. It pulls 14.2 amps when it's regular cool temperature outside. In the desert, it pulls 18 amps. So maybe 20. Maybe 20 works. If it's 20 amps, and she uses it during the hot summer, so this is one thing you can do. If she uses this in the summer, we're going to keep it at 20 amps. If the 20 amps does a nuisance break, so that she's running it and then it trips, and she runs it and it trips, then you would upgrade. But it's possible. With it, we're only pulling 14 amps. That, it's not ever going to be an issue. So that's what you can do is, if you don't know, start low to be safe, like 10 amps, 5 or 10 below what the max is, and then if you have issues with it tripping, going at like a nuisance fault, like it trips more than it should. You can go up. So this is 18 amps. So if you went to like 25 or whatever. Now your owner's manual is going to tell you what you need to have. Because if you go above this number, 18 amps, that's where it gets dangerous. Because what happens is it's not going to trip because you've oversized it. And that's not good, because what we're doing is we're initially sizing for the wire, and you don't want to go over the wire capacity. So forget about the AC unit or like the switch. The breaker is protecting the wire. if this is oversized too much and it does not meet the specs of the wire is just going to get hot. And that is how vans burn down. You don't want to do that. So we're sizing the fuse to the wire. Now, if the wire, I'm going to make an example. Say the wire can go up to 50 amps worth of power. So it's up to 50 amps worth of power. Well, if we have a 25 amp breaker, because our appliance is only going to be using, our appliance is not supposed to use more than 30 amps, and we want it to break at 25 just to be safe. We've got a lot of headroom on the wire, so we're not worrying about the wire failing in this scenario. We're protecting our appliance. So that's usually why I tend to oversize my wires in my van builds, because one, if a customer adds something down the road, and I don't know that, it gives them just a little bit of headroom so that there's a little bit more safety factor in there. Also, if I build the van, and let's say we're on a 12-volt system, and the customer after the van's done says, hey Nick, I want to add Starlink and can I add this? I don't have to run new wire. I've oversized the wire enough to give enough room so that I can add a couple different components. But the point of that story is this breaker, the breaker, don't think of it, it does have a relationship with whatever component you're running, but the breaker is there to break the circuit before the wire has more current than it's designed to handle. That's what breakers are for. It just happens that the relation to whatever appliance you're using, you can factor that in. So hopefully that makes sense. I know that's pretty technical, but that's stuff you should think about when wiring. Rod says she should eventually get a 12-volt fridge. Yes, but that's very expensive. This is a very, very budget build. This customer is already, this is a very exciting project for them. So this is kind of like a splurge. Even though we do very expensive installs here, for this customer, this is the splurge. Even though we're using these components, but this video is to show you can use these components to replace this. So this is the upgrade. So we're going from lead acid and little baby 1000 non-pure sine wave inverter, very important. If you're going to plug in computers or anything, do not get a modified sine wave. It's over time it can damage your electronics, cell phones, computers. So yeah, so just be aware of that. So next we have some more components here. All right. Cooler style. I'm not sure if you're talking about the components or other things. All right. So guess what? All of this stuff that we're putting in here, we got off of Amazon. So that's another bonus for so take this video as this is a good first time DIY install setup. So if you've never gotten into this stuff and you're getting these components and you're like, oh man, I don't have Victron, this is, this is good, this is nice stuff. Again, I have this in my personal van because, I got to put the other money into the business. So I'm not going to go crazy on like a $5,000 inverter. It doesn't meet my needs. I might have somebody that does need that high, expensive inverter. All right, terminals. Make sure that you get UL listed terminals. Don't get 10 copper cheapos. This is where you spend your money. You spend your money getting nice copper products like this. All right, what's in the next bag? All right, see? Right here. Anyway, I like these. You also want to measure from the manufacturer or from your batteries. You want to find out, okay, these are going to be connected to these terminals. So you want the diameter of this to be the same as your, I think this is M8. You want these to be the same, okay? You don't want a big lug on a small screw, and then a small lug on a big screw won't work. So think surface area. We want as much surface area of this lug to touch and make it safe. All right, so there's our lug. So these will connect to this. These, Alexa, stop. Alexa, stop. Yeah, these will go to here in the battery, and these will go to this. Let's see what we got here. All right, next we have our 80 amp fuse. So this 80 amp fuse is going to be used for the DC to DC charger. Because, okay, we're protecting the wire. That's why it is that size. Next, we have a terminal fuse. This terminal fuse is going to go on the battery. This is a 300 amp terminal fuse for our 230 amp hour lithium battery. This is our 300 amp terminal fuse, which goes over here. You have to buy these. They don't come in a kit. I don't know why. You have to buy them separate. So this goes on here. And so what this does is, this battery has a built-in disconnect, but we need redundancy. So if it fails, we need something to protect it from damaging this, or vice versa. If this messes up because we accidentally plug into bad shore power at a campground, and it just zaps to this, and it's going to zap the battery, then hopefully this will stop that. Highly unlikely that you're going to get 300 amps, over 300 amps coming from a campground. But you never know. You know, wild things can happen. Oh yeah, I forgot about this. So a battery monitor. How do we know how much power is going through the system? So here's our battery monitor. Again, this is another white labeled product, and what that means is you may see, instead of Renogy, there may be another manufacturer that has this exact same piece of, which don't see that as something bad. See that as multiple manufacturers using the same thing, so should be it's a good thing to see, in my opinion. This is the shunt, so this is what is going to go in between power coming into the battery and power coming out, and then it's going to display on this screen, and it's going to tell you it's the battery level. Okay, so in the back of her van, we're going to have both of these. It might not be in this orientation, but the plan is to have these two things right here, just like that. Let's see, I wanted to, let's see, maybe, okay. All right, let's keep going. The disconnect switch, I wanted to fit the disconnect switch in there. So let's keep these out. There's our disconnect switch. Okay, this looks overkill, and you're saying, Nick, you got a budget system, but you're buying like this overkill Blue Sea Systems stuff. This is okay if you want to go to more budget, but these components, the components that keep you safe, I only use Blue Sea. It's just my thing. This is the stuff that keeps the other stuff from going not good. Also, if you're doing a 300 amp fuse on a 230 amp hour battery, or just any, this might be the best example. You can have 1,200 amps worth of power coming from your battery bank, but each individual battery is typically not going to be over 300 amps per battery in the circuit. So you might have one 100 amp hour battery with a 300 amp fuse. That doesn't make sense, but what you got to think is, say you have these all in a row, and you do have a second alternator, and that second alternator is pushing 285 amps to charge the battery, and you want to have the appropriate fuse to protect the battery in that event, and kind of vice versa. The point that I'm getting at is your disconnect switch has to handle whatever juice you're putting in and out of the battery. So on these Nova, so this right here, for example, is rated, if you look right here, this one is rated Nova. So this disconnect switch is rated for 350 amp continuous. So let's do that right there. So you want the disconnect switch to handle your maximum possible current. As you can see here, we have 5 minutes at 600 amps, 1200 amps cranking. So this, it's a little overkill, but I do like this because I can do a hole saw, push this through, and it's just a nice clean disconnect. So that's why I'm using this. So again, yes, it's overkill. I got it. Here is our, so this is what is going to be coming from the engine. And this is our fuse coming from the engine to the DC to DC charger for charging. So that's our 80 amp fuse. This is 30 amp, but this is not our limitation. We've limited it at the charging box. And that is because we don't want to tax the alternator. But the wire, the 6-gauge wire that is running to the back, this is what we've got it set for, if that makes sense. And then this one is extra. Okay. All right, hopefully that's all making sense to you guys. Who is on the live stream? Do we have any questions? Man, we got 7 people. That's pretty good. That's pretty good for not streaming in a while. Okay, those are the products. Let's get back over here and do some fun stuff. Just taking some stuff apart. We'll see how far we can get with this. I'll stream longer if you guys ask questions. How about that? Okay, here's the box. This is what whoever installed this decided would be a good idea. I don't know, maybe this thing is 20 years old, this install. I guess there wasn't a lot of lithium. I mean, I don't even know if there was lithium battery options then. Basically what we have is 2 wing nut screws that are holding this whole thing together. Okay. All right, so we take this off. You can see this is what little contraption, and see it wasn't sealing anyway. So now what do we have in here? We have a interstate battery. It's a deep cycle 600 cold cranking amps marine RV battery. So that is what that's what they had in here. So next thing I want to do is disconnect this from the engine, and then we can come back here and then start taking a bunch of this stuff off. And the more I get into this, I'm not sure how much I want to move or take apart. The plan is not to do too much because we are trying to do a budget install. But this thing is glued, mounted, so it might take slightly longer than we anticipated, which happens. Yeah, so let's go ahead and disconnect it from the engine and keep on going. All right, guys, this is the long part of the live stream, so now we're going to get into not so much talking, a little bit more working. So if you guys want to come back and watch this later, that's cool. Or you can stay tuned and just watch me work in the shop. The battery terminals are super rusty up front, so let's see if we can clean those up too. Alexa, turn on workshop lights. All right, so we got the negative terminal disconnected. I know you guys can't see that, but that is what just happened. So I'll be back at the camera in just a second. I'm just disconnecting these terminals before we get started at the back. These things are rusted crazy. You gotta be careful with these rusted. I know you can't see this, but it's possible to break off a battery terminal, like from the battery itself. Okay, we're disconnected on the negative side. We're gonna do a little PB blaster, and then we will come back to this in a second. If you guys don't know what this is PB blaster. Loosens, it's just a penetrating oil, loosens bolt. Okay, while that's going, use our multimeter to make sure we don't have any juice coming back here. Obviously, after we disconnect this stuff down here. So you always want to take pictures, even if you're never going back to whatever you are working on. You just need to document how things were connected so that as you work on it, if something doesn't work the way you expect it to, you can go back and figure out if it was something you did or if it was something that was already not correct. Okay. All right, so we got that disconnected. Next, we will disconnect the... I do want to give you guys a better camera angle, but the problem is this tripod. Okay. And just curious, I wanted to see how charged this battery was. Six, yeah, 6 volts. All right, doing great. All right, so they bolted this down in here. Since I'm not going back, I might cheat and use a regular Allen wrench. These are Torx bits, but sometimes you can get away with using a Allen, which actually looks like that's not going to work. Nope. Nova. It is just one size off from what I have. It's probably like a T16 or 20. This is like watching paint dry. That's a good one. It is. It's live van building. If you want to watch finished videos, there are completed videos on the channel under videos, but live stream is live. It is unscripted. That's right, Rod. This is like what this is turning into. I've got a T15 and I've got a T25 Torx. I cannot find my T20. I don't know who uses a Torx screw to bolt down a piece of plastic in a van. That makes no sense. I could drill it out, but I mean, I'm one Torx bit away. I just finished up 2 vans, and this is the, here, I think I got it. This is the aftermath about doing 2 vans and not putting all the tools back where you got them. Jesus, come on. Look at this. The one that's missing is the T20. Jeez. We did not find the Torx bit. Should have done that earlier. It's much easier. All right, what other stuff am I going to uncover? All right, the next thing is this wire from the shore power. They didn't glue it down, but man, there's a bunch of holes. So yeah, the simple install. All the screws in here are all like security or Torx screws. It's so wild. All right, that should be this. Should be this one. They're using square head screws. Square head. I have no clue why. Take those photos. This has proved the point that if you are doing a van build and you're doing a DIY build yourself, just take a little time to do a little bit of extra planning. It will pay off. This one, that is going up to AC. Okay. So we should be able to keep this cable. The ends is just bad over here. I just need to make sure that the end is safe on this side. But everything here looks nice, looks good to go. This is coming from our 12 volt source over here, which is not done correctly. Let's cut that off. It's a 12 volt input source, and then these are our positive and negative for our battery. Okay, the negative. What do they have it going to? Okay, the negative is connected to the chassis. That is surprising considering everything else that is going on. That was actually done very well. So we're happy with that. So we'll keep that one. All right, so we'll keep you. You're gonna hang out there. We've got some type of wild 12-volt cable going somewhere. Where is that going to? Okay, 12 volt. We're there's a 40 amp fuse on a 12 volt positive cable with no. Hold on, my microphone. Okay, there's a 12 volt cable. We don't know where this thing is going or is coming from. All right, there is a TV in here. Somebody did install a TV, but I can't seem to think that that line would be what is powering this TV. No, this TV is not. Well, there is a, wow, okay. Okay, we're just going to, we'll find out that later. It's not part of the main project here. So this guy, we don't know who or what it belongs to. There is 12 volt fuse here, 40 amps, but okay. So this next thing that we have is we got the 12 volt. This was supplying power to the inverter. So this is coming from, this is just a battery cable. So you're just powering the inverter only off the battery cable. That makes sense. So this is nice. We can reuse this if we need to. We'll just throw that on the floor right now. Next, we are going to, we got a good ground. We've got this white wire, which was going to the inverter. So we don't need that. We've got our wire going to our AC. And then we've got our shore power. So we're going to undo the shore power. If we can clean the wires up and reseal it, then I'll be happy with that. We won't have to completely redo that part. So I'm just outside the van right now, undoing the shore plug from the sheet metal of the van. And didn't think that they would glue it, and they did not, thank God. Okay. All right, not as bad as I thought it would be. All right, do I have enough camera movement to get you guys over here? There we go. So safety-wise, this is what I wanted to check. It looks like it's cutting into the wire. If it is, we'll re-strip it. We got enough slack here. We can redo it. It's working fine. There's not like a bunch of rust here. I'll actually put some more rust preventative on there and keep going. Okay. Hey Nova, how are you doing? Is it time to get some food? All right, it's not bad. It's not bad. Now we're just going to slide this over. this. Yeah, so I'm going to replace this because I don't like. The cable's good. This is just, this would work for probably another 10 years, but I don't like how this whole thing is. The trick on these is these wires hit the inside and they fray. You can use a ferrule, but if you get the right wire and the right ferrule, it'll work. But in this case, I don't have a ferrule for this size, so we're just doing it old school way. Okay, really make sure that we got these in there. And then I'm going to wrap this just to clean it up a little bit. But this will make me feel better when she is plugging it in and out, because that other one it's just dangerous if you don't know that it's going to make a good connection or not. Feral cat. You guys are funny. All right, now I feel better about that. That way, my quality is usually driven by, did I do it correctly to where I can sleep at night? Is this safe for somebody plugging into an outlet? So now this feels good. Oh man, I knew I did that. The gasket, this foam gasket, man. I tell you what. Can I get away with this? Can I get away with this? I don't know. Maybe? Amazing. Look at that. I did not think that would work. All right. Excellent. I'm not going to bolt it in yet, so because I need to clean this up, but I just want to do a quick test fit. Yeah, that's cool. Somehow the screws are standardized. That's nice. I'm still going to do some silicone. Actually, I use black RTV just in case it comes out a little bit on the edge. It just looks professional. But there we go. Now she's got a new outlet. I like this one because the light turns on when it's getting power, when the cable's getting power. So I like that. All right, let's get this dialed in here to where we can tighten it down. Nice. All right. Happy with that. Okay, check that off our list. This thing is done. We're just going to clean it up. Rust preventative. We'll probably do that after we grab some food. Out with the old, rusty, nasty, possibly dangerous. This is what I don't get. Back in the day, they used, this is like a conduit clamp. And so it's just cutting into the wire. This is all plastic now, so that makes it much better. Let's see here. Butyl tape. You can use butyl tape. I use butyl tape for stuff on the roof. You can use butyl tape for this, 100%. I don't like how butyl tape oozes out. If you use butyl tape and you put it around a joint or whatever, when you tighten it down, it'll squeeze and squeeze out, and you'll say, "Oh, okay, cool." And then you'll take a little razor and cut the excess off. You'll come back in like an hour or two, and it's still oozing. It kind of has like a mind of its own. So for this one, I just put I do black RTV, and then I'll just seal it. Seal it around there. Is that thing not in focus that whole time? Yeah, so I'll do that. All right, back inside the van. Okay, so we got that taken care of. What else do we want to do before we do a little dinner break, late lunch? Romex. You don't want to use Romex in the van. You can. I've done it in my van. The reason you don't want to use it is the concern is over time it can go back and forth under vibration. It can break internally and fail. That is true, but this is not part of my install. As far as rewiring goes, but just in the future, don't use Romex if you're doing your own van build. You want to use the stranded copper wire. Specifically, I recommend using marine grade. That's the best thing to use. But it's very expensive and all that good stuff. But this has been working fine. She's had no issues, so we're just going to reuse that. So they have this coming out of here, which that's fine. But what we need to do is we need to take this out. So the next part of the project is going to be, we need to unwire. So we'll take a picture of this, and we're going to unwire the direct one-to-one connection from the shore power to the breaker panel, and it's going to bypass and go into the inverter charger, then into the breaker panel. Yeah, so we're going to be doing that. Where's my screwdriver? Yeah. So, for example, I'm calling it the Texas build. The couple that I'm working on their van, hopefully it'll be back in this week. So this is what you want to use right here. See this right here? This is Anchor. Hold on. I would keep turning this on manual focus. All right. This is Anchor Marine Grade. This is 12 3-wire, 100 feet. This is the type of stuff that you'd want to use in your van specifically. What's so nice about it is it's double jacketed, so you actually have an outer jacket. It's pretty abrasion resistant, and then you get the individual wires on the inside. Again, you just want to make sure that this is a UL listed product. It's important. So anyway, this is what I normally use in the van. But for these, I don't want to call them odd jobs, they're just different jobs. Because I directly wired my fridge with a Romex cable because I built my van like 4 years ago when I first started this business, and you know that's what I had. I didn't really. Actually, it was left over in the mountain house that my parents had, and I just used it because it was available at the time. And yeah, it works fine as long as it doesn't flex. You know, it should be. It'll probably outlast the van, to be honest. But yes, by the book, marine grade wiring. That's what you want to use. The appropriate gauge. That's what you want to use. Speaking of appropriate gauge, let's just triple check this. What this is. So 12 gauge. 12 gauge. Let's just double check. Okay. So it's 20 amps. Yeah, Rod, so for 14 gauge, remember the gauge of the wire is how much accessories you're going to add to it. So just blanket doing, and I'm not saying this is you, but just blanket doing 14 gauge and hoping it's okay. What you want to do is, have a plan for that wire. So if you get a 14 gauge wire and it's doing one, LED light, I mean, in the future, you can probably connect as many as you want. You'll never go outside that range of the wire. But for example, if I do 12 gauge, so 20 amps. So this is a perfect example. That Romex is a 12.2, so it is a 20 amp max. Now, technically on paper, if this is the same AC unit, in the worst case scenario, the AC unit is going to be pulling 18 amps. So the worst case scenario, 18 amps. The wire can buy 20 amps of power. So I'm okay with that. The breaker's a 30 amp breaker. So, that is technically I would change that to a 20 amp. I may do that. But we need to see how the AC unit runs. If it's okay, 'cause here's the thing. This is where all the experience comes in. The surge amperage on an AC unit, it might peak just for like a second, literally like 1 to 2 seconds, maybe even half a second. There's a surge current. So the AC compressor might draw 30 or like 40 or like 30 amps or something like that for just a split second. But when it's running, it's never going to go above 18. So that's kind of the, if you size the breaker for 30, the line's 20. Even though that line, you would want it to technically be like 10 gauge or something like that. But it's only going to be at that higher amp for just a brief second. And so usually that's why those breakers are sized at 30 amps so that it doesn't trip the breaker right when it kicks on. It's not that during its running time that it actually, so say, for example, so see here, this says, like normal conditions, it's pulling 14.2 amps. Hot, super hot outside, and this is desert, 18 amps. So, yeah. The best way to do it, it's expensive, but technically the best way to do it is to have an amp meter and be able to, while your system's running in real time, see how much, the surge current and then what it settles down to. I know that's that's kind of outside, what you might be capable of at the current moment, but in a perfect world, that's kind of what you want to do. That way you can see what you're using. So, this, when you turn this AC unit on, it might, like just a microsecond, be like 30, 40 amps, and then go back down to 14. And so the copper wire is not going to, blow up. It's going to take a minute for that wire to heat up. So if you can think about it like an oven, when you turn the oven on, the oven coils, they're not instantly hot. Like it takes a while for it to turn that black color to red. And so there's no difference in the wire in your van. So you might have that bump surge, and that might be why they've oversized the breaker to 30 amps. I'm hoping that's why they did it. But it's oversized so it doesn't do a nuisance trip. Turns on, runs, and then now we're running at like 14 amps on a 20 amp max Romex 12-2 wire. Everything's safe to go. So hopefully that made sense. So even though like an AC unit you might buy comes with a cable or whatnot, just make sure you understand that, oh, I see the cable it came with is this gauge. Does that make sense for what I'm connecting it to in my van? Does the manufacturer's recommended fuse make sense mathematically to what they're suggesting me to put in? Because sometimes these manufacturers will tell you to put in an oversized fuse. I'm not saying who, but they might say, they might give you like an 80 amp fuse. Like for this RTX 2000, for example, I think it needs an 80 amp fuse. And that's just to make up for that surge. It needs to have room for that surge when it first cuts on. But it doesn't run at 80 amps, obviously. So hopefully that made sense. All right, I'm going to do this for 10 more minutes, and then I'm going to grab some food. So let's go in here and take out, let's see here. Got some wild grounding going on, but it's okay. What do we got here? So that is the box operating. We just want to take out this. Okay, so we're going to make sure we take some good pictures of this. it's going to go back the way we want it to go back, but let's just take a picture of this. Right there. Okay. Figure out what that goes to some other time. Man, I'm just, the amount of tools that it's taken to take this thing apart is insane. Square head, Phillips, flat head, Torx 20 that I decided to just drill out. Probably should have done that earlier. Now we're in flathead territory. Yeah, so 10 gauge. And you can go online and just say AWG 10 gauge MAX 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 amps. I'm just going to spit out 30. So as long as you're typically going to be taking 30 amps and stepping it down to 15 amps. Unless you're using the inverter charger, which it will be 30 amps. So, yeah, and I like Explorers.life. They're good. And I learned a lot of stuff from him too. So, I mean, I would take his recommendation on what he's providing you. But remember, his kits are based on a kit that is rated for if you're only pulling 30 amps, you should be fine. Just remember, whatever inverter. So Rod, what inverter are you using? Yeah, if you know what inverter you're using, I might be able to figure out. I might be able to do a little double check for you. Okay, so we got this black, the line, the ground. So our neutral wire, that's the next thing we got to take out. All right, let's take this out. The 3,000 watt Victron inverter. So the only thing you want to do with the Victron, I don't know if it maxes at 30 amps. I don't know if it has the potential to do like 50 amps. You're just going to want to make sure that it's set to where it never exceeds 30 amps charging. I think there's a little controller that comes with the Victron, and you can dial in how much current you want pulled through it. So, yeah, I think that is. All right, guys. So see over here, we just took out. This is what we just added to the shore power. So now I'll pull this out. Okay. So now there we go. This is our shore power cable. All right, so this is 12 gauge. So we're still good on there. We're still got, but she's only using 15 amps. She's plugging it to her house. She has a converter right here. So she'll only be having actually only doing 15 amps in. Yeah. So Rod, you'll be able to, in that system, you can dial in how much you want the inverter to pull from the shore power, to the plug at a campground or your house. You'll be able to dial that in. And so I think you'll be able to dial in, you can do like 25 amps or like 28 amps. You can just do like a little under 30. And then that way you won't have to pretty much worry about anything. All right, what am I doing? It's time for some food. This is why my brain is going here. All right, so these are the two power wires that power this board. So let's see. Two, three, four. Okay, makes sense now. The 40 amp is for this. The 40 amp fuse is for the box itself. So that is what's controlling the cooling fan. Gotcha. Okay, makes sense. All right. Okay, we've simplified this now. So now our next step is we'll be going through here and awesome, yeah, thanks for watching. Appreciate it. Thanks, Rod, too. I'm going to undo this one last part here, and then I'll probably grab some food. So if you guys have just a couple of final questions, I'd be happy to answer them before I hop off here. Yeah, let me know. Okay, well, we got a question here. Hey, Chris. Thanks for chiming in. I haven't forgot about our conversation. I've been swamped lately. So the Texas van, his customer's van, it is in the, there's like a little, he was driving up here and there's a little scratch on the side of the van. Maybe you and I talked about it, but I just dropped it off in the shop end of last week. And then this van is a lady's that we had scheduled for Monday. And I rescheduled it for Tuesday, and then now I'm just getting this thing knocked out. So, yes, we will chat very soon. But her van, I'm trying to get it knocked out before this little snowstorm hits us. That's kind of what's going on here in the shop. Yeah, if you're just tuning in, this is a this is a wild little. This was supposed to be just like a day and a half project, but anything that I see that I'm not comfortable with or need to redo because I don't think it's safe, I'm just going to go ahead and do it because, yeah, she's traveling by herself in this van. She's a banjo player. She travels out, goes to music festivals. Really cool story behind the owner of this van. And what we're trying to do is, she had a lead acid battery. So the previous owner did all this work, and then she bought it. But then when she got it, she found out the fridge ran off this lead acid battery, so it only ran for like maybe a couple hours. And then she tried to turn her AC unit on, but the AC unit only runs when it's plugged into shore power. But the battery for the refrigerator only charges when she drives. So this whole thing was just it was not working. And she's trying to go travel cross country. So that's the plan. That's what I'm trying to get her all set up for. So what we're going to do is we're going to install for her a new lithium battery. So we've got a, believe it or not, we've got a lead time battery that's going in for her. Oh, cool. Yeah. I'm looking forward to hearing about that surprise you got. Sometimes it's good to like let some ideas kind of stir in your brain, and then usually you kind of figure something out with some downtime. So if that's what you're talking about. All right, so what we're doing here, can we see this on camera? There we go. So we've got a lead time battery, and Will Prouse, the DIY Solar YouTube channel, he rips apart batteries, and he'll tell you about budget batteries that he feels comfortable recommending, and this is one of them. This is a 230 amp hour with a low temperature disconnect, and it was about the only one that had more substantial battery, but also fit in here. So fits really nice. So you know what? Might be changing my mind here. Can I fit the invert? I don't think I can fit it. 2110. This is 10. This is man, this is so close. Maybe I can put this in the back side. Anyway, what we're doing is we're taking this 230 amp battery. This is going to run the fridge. In my personal experience, a 100 amp hour battery on a 110 fridge that's in my van will last for 2 days at 100 amp hours. So 230. This should get her almost a week, probably a solid 5 days. But she drives the van too. We got 30 amps charging this. It's not a lot, but if she takes long trips, that's going to top this off. But she's mainly going to be at campgrounds with shore power. So that's her main source of power into this battery. She's going to be at the house, mainly hooked up to her house. So we're not really worried about solar. We're not really, the engine charging it's already there. So we're just tapping into it. Anyway, so yeah, we'll probably just put the battery where it was. Man, I'd like to put the inverter there. Let's see. Oh man, making decisions live. Yeah, I like his channel. It's just so the real world testing and the real world feedback is just it's just good peace of mind, especially when you have customers and you're trying to, you know, instill confidence that your decision is something that you've found research on or done some research on. Gosh. Yeah. I wish I could show you guys the inside of this van. It's so wild. Whoever did this install, they were trying to vent the lead acid. So, but there's just tons of holes all drilled and cut into this back of the van. Yeah, to be honest, I really want that. And I think that inverter back here in the back, it just feels like that's where it's supposed to be. Because that battery's so slim. So, what do we got here? Oh yeah, his house is awesome. He's got, well, I mean, besides being very successful with all the, you know, he's got like, you know, the Tesla, the camper conversion that he did, you know, all that solar at his house. You guys are using like straight copper, solid copper wire for all these grounding loops. It's very funny. So we're gonna cut all this out. Okay, I think what I'm going to do is I'm going to leave all this structure. Probably from here over, I'm probably going to cut it out, reinforce this, because this is just, I don't know. I'm not a janky work type person, sketchy work, whatever. I don't really like to. Wasn't really the scope of this install, but I just don't like. I don't like how this is going together. So this is the fridge. We're not now. This is Romex, yes, but we're not going to be rewiring this. This will be just the way it is. But this we will need. We will need a breaker. So let's see here. I'm going to take this out, and then I'm going to grab some food. I will go pick up another breaker. And we're just going to do a these need to be the outlets, and then this. All right, why are they doing this? So this goes to. All right, hold on. They decided to have this AC on a 15 amp. We'll get a 15 amp, but I don't think that's accurate. That's correct. Panel rating, 30 amps. So technically it needs to be 30. All right, so we're just gonna take this out. Let's take this with us. Get a stink bug inside. That's wild. All right, we're gonna take this breaker. For the heck of it, let's just see if it's on the computer. All right, so we need a. This is a Westinghouse type BRD. Come on, Lowe's. Uh-oh. What is compatible with a BRD? So, compatible BRD breaker, Home Depot. All right, that looks like our thing. So BD. So BRD, I don't know what BRD means. Okay, we don't want to add anything else to this van, so I think this one, this 20 amp one, they got in stock. All right, they got 52. Perfect. Okay, so what we're going to do is we're going to use this one for the 2 outlets in the van, and then we're going to buy this one for the breaker for the panel itself. But I'm going to go to 30 because if all this stuff is on, I don't know why. I think somebody just, see, this is what you kind of have to like do this like investigation. Somebody just bought this 2 15s, and then they use one for the outlets and one for the, that's not what we want to do. So actually I need a 30. So a BR, see, we're learning all kinds of stuff. We need a BR30. Does that exist? Eaton, 120 single pole. Got 7. Okay. So we're going to get that. We're going to get a, they got 15? Okay, we're going to get a 15 and a 30. And then It's only $7. All right. Get this list together. So life hack is take a picture of your screen at the aisle that the product's on. That's what you want to do. Okay, so breaker, check. 2 outlets, check, we got that. We know what our 12 volt power is going into with a 40 amp fuse. We figured that out. We have no clue what this is. So I'm going to cut this, and then if I need to rewire it, I'll do that later. It's this thing, so I'm just going to take this and twist it here in a little knot. I have no clue what this is for. You want to terminate stuff that you don't know what it's for, because I don't want anything to short the work that I'm just now figuring out. Okay, so these 2 white Romex are the 2 outlets. They're fine. This Romex here is for the AC unit. That's fine. In a perfect world, we'd have marine grade wiring, but that's not the scope, again, of this project build here. Going through, and we're just cleaning up all this wild stuff here. Got some crazy ground wire over there. I will say, whoever did the ground wires are not bad. Okay, so we do all that. I want to make like a little elevated platform. All right, guys, I think we got a game plan for this whole thing here. So cut a couple pieces of wood. We're just going to elevate this thing about 1.5 inches. We'll tape over these holes, get them sealed. I want to mount the inverter here, and then the battery just back behind here. So it's just not taking up her whole area. Okay, that is the plan. Let's see what else here. All right, that's the plan. All right, guys. Thank you very much for watching this live stream today. If you have any questions, put those in the comments below. Make sure you guys are subscribed, like the video, share it to anybody that needs help with this type of electrical work. I do have a van course for sale on the website, vanbuilderhq.com. You can find that link in the description below as well. And if you're looking for some free help, there is the DIY van build cheat sheet. So it's essentially an Excel sheet of all my Amazon purchases over the last 3 years, organized, and all you gotta do is click on the link, put your email address, it'll send it directly to your inbox, and you just go through a bunch of parts. A lot of this Renogy stuff is on that list. So should be very helpful. There's solar panels and stuff like that, water pumps, all that good stuff to help you out. But okay, that might do it for today's stream. I'm not sure if I'll stream again tonight. You might see this thing maybe finished tomorrow. So, yep, that's it. We'll see you guys in the next live stream.